welcome back with another problem. Here I have a problem that is related to magnetic field as well, but it's like the uniform magnetic field. So in this case, I'm skimming through the problem and I can see that there's quite complicated in this one. So I'll just highlight all of the significant values that are needed in this first, because this would be something that would appear in exams. I think it's like all the complicated stuff. So here I have the initial kinetic energy, and there are two regions, as you can see. And you know that the formula of the kinetic energy is K is equal to 1 over 2 mass velocity over square. So the question is to find the velocity. So we can just take it from the main equation that we think of earlier. We can have this one. Okay, and we can substitute all the numbers that we have for the kinetic energy is 4 kilo electron volts, and we have to also change this unit into normal unit that we usually use in physics as well. And it is supposed to be, let me write this in the expansion. So it's 2 multiplied by 4, and kilo is like 3, right? So we multiply by 1.6, multiply by 10 to the minus, so that we have the unit as joules is the standard value, standard measurement units for our problem. Our subject. So there we have the mass that we all know is 9.1 or 9.11, and it's very, very small because it's just a particle, so the unit is kilograms. The answer that we got is 3. ms. Don't forget to write the units because they're very important in physics, and you can just get your score reducted if you forgot all of those. Yes. So here we've done. The next one is how we're going to find the acceleration. So the acceleration is we can say that it's the distance that is divided by the square of time, but in this case we're using the first Newton's law, F equals to ma, and acceleration a is equal to F over m. And we have this one as the EQ over m, while this one we can be written as delta V over D, like this. It is from the formula of the potential difference, VED, V equals CED. So this one, there's also another equation that you need to use as well, is the distance, the Stewart's equation, Vt plus 1 over 2 at squared, and yes. So to make it easier for you guys to like transferring all of those numbers to find something, you can just substitute first and then you can find it later. So we can substitute it by 25 multiplied by 10 to the power of minus 2 equals to 3.74 plus this number 1/2, and the acceleration is from the formula that we have figured out earlier. So this 2000 volts are from this number here. So you can just go back and forth with the problem in order to see what's going on with the problem that we are solving right now. You can also remember, or I think in the exams there are going to be the numbers that are given, but for your confidence you can just remember all those numbers if you want to. And t squared. So actually in this problem they're finding t. So we're finding there are like sub questions that are hidden, and we need to make sure we find a way for t in this problem, even though we don't know where to start. But we can just start by giving all the hints, because they're giving hints about the kinetic energy. So first you have the formula for the kinetic energy, and you can find the velocity, and then you can find the acceleration, because acceleration is connected to t that they're finding. So you can think of the formulas in each chapter, and then you can find the answer easily. After that, you can just find and substitute for the t. So I've done the pre-calculation, and I can find that t is equal to 5.99 seconds. It's really short. It's like it's really fast, you know. It's really short of time because it's to the -9. Yeah. And we can just like compare it to as 6 this way. Similar to 6 nanosecond, don't you think so? Yeah. Power 10 to the power of -9 is nanoseconds, right? If I'm pretty sure. I hope I'm right. Yeah. So after that, there's a t prime, because we're not actually finding the actual t, we're finding the t prime that is the overall stuff. And here you have over EB. So all the formulas, you have to remember them and to figure out which one to use for each kind sets of questions. So we have in this one as well, we have two B regions. I mean the magnetic fields that are, this one is outside and this one is inside to the page. And they are having different values. So you also have to find the total magnetic field as well. So now you're finding the magnetic field. B is equal to 1, like this. I mean, this way around, sorry. So B is equal to 150 Tesla. Therefore, you have everything else in your hand. You can just find this one easily. The mass, the charge is still the same, no matter what. It is still a particle, it's still an electron, therefore it's always the same. So here we have 2.6 seconds. If we compare this number to this number, it's not that much difference, because from around 3 to 6 is similar together, but we also need the total time because the question that they're asking, what time does it leave? So what time does it leave is considering all the time that went through it and the half circle of it. So yeah, we have to plus t, total t is equal to t plus t prime, which is 6 plus 2.6 to the power minus 9, and we have 8.6 nanoseconds. That is the answer. You can find the file of the answer in the description box below. Thank you.